Welcome back to the Aptos developer course. Today we are getting in the deep end of Move programming language. If you've been following along, you've already got a solid understanding of the basics. We've covered resource-oriented programming and created some simple smart contracts. But guess what? We're just scratching the surface. Move is a powerful language with some seriously cool advanced features. Today we're going to level up your Move skills and explore some concepts that will take your Aptos development to the next level. We'll start with generic types and abilities. Trust me, these are game changers when it comes to writing flexible, reusable code. Then we'll dig deeper into structs and resources. There's more to these than meets the eye. We'll explore Move's unique ownership and borrowing model. If you're coming from Rust, some of this might feel familiar. We'll also cover advanced error handling techniques to make your code more robust. And finally, we'll take a tour of the Move standard library. It's packed with useful tools that can save you tons of time. Alright, let's start things off with generic types and abilities. If you're coming from languages like Rust or C++, you might be familiar with generics. In Move, they're a powerful tool for writing flexible, reusable code. Now imagine you're writing a function that works with different types of assets. Instead of writing separate functions for each asset type, you can use generics. Here's a simple example. In this example, T is a generic type. The store part is an ability constraint, which we'll talk about in a moment. Now let's talk about abilities. In Move, abilities are like superpowers for your types. There are 4 main abilities. Copy, types with this ability can be duplicated. Drop, types with this ability can be discarded without explicit destruction. Store, types with this ability can be saved to global storage. Key, types with this ability can be used as keys in global storage. Here's how you might use these abilities. In this example, my FA is a generic struct that can hold any type T that has the store ability. The struct itself has the key and store abilities, meaning it can be stored in global storage and used as a key. These abilities might sound like small details, but they're crucial for writing secure and efficient Move code. They help prevent common errors and make your intentions clear to other developers and to the Move compiler. Now let's look at a more practical example. Say we are creating a generic fungible asset pool. In this example, we've created a generic pool that can work with any fungible asset type. The phantom keyword is used because T isn't actually stored in the pool struct. It's just used to parameterize the type. The power of this approach is that we can create pools for different asset types without duplicating code. We could create a pool for Aptos coin, a pool for a custom token, or even a pool for wrapped assets from other chains, all using the same code. Generic types and abilities are key to writing flexible, reusable Move code. They allow us to create abstractions that work across different asset types while maintaining type safety and resource safety. As you start working on more complex Aptos projects, you'll find these features really useful. Alright, let's take our understanding of structs and resources to the next level. We've been working with these types from day one, but there's more to it. In Move, structs are the building blocks of our data structures, but resources are where the real magic happens. Remember, resources are special structs that can't be copied or discarded, they can only be moved. This property is crucial for representing assets on the blockchain. Let's start with a struct example. In this example, we've created a more complex fungible asset structure. Notice how we have nested the FA info struct within our advanced FA resource. This is a powerful way to organize related data. Let's talk about some best practices for designing structs and resources. Single responsibility. Each struct or resource should have a single well-defined purpose. In our example, FA info holds basic token info, while advanced FA manages the overall token state. Immutability where possible. If a field doesn't need to change, consider making it immutable. In Move, we do this by not providing functions that modify the field. Access control. Use private fields and public accessor functions to control how your structs data is accessed and modified. Consistent naming. Use clear, consistent names for your structs, resources, and their fields. This makes your code more readable and maintainable. Remember, in Move, resources are our way of representing unique assets. Not just data containers, they're a fundamental part of how we model ownership and transfer of value on the blockchain. Now let's talk about one of Move's most powerful features, its ownership and borrowing model. If you're coming from Rust, some of this might feel familiar, but Move takes it to a whole new level. In Move, every value has an owner. When you pass a value to a function or assign it to a new variable, you're transferring ownership. This is called moving the value. Once the value is moved, you can't use it in its old location. This might sound restrictive, but it's a powerful tool for preventing bugs and ensuring resource safety. Let's look at an example. In this example, transfer FA takes ownership of the FA resource, destroys it, and creates a new one at the to address. Once we've moved FA, we can't use it again in the function. Now, what if we want to use a value without taking ownership? That's where borrowing comes in. Moves allow you to borrow references to values, either as read-only or mutable. In our borrow FA and borrow FA mute functions, we are borrowing the FA resource from global storage. The acquires keyword is crucial here. It tells the move compiler that these functions need to access the FA resource. Why is this model so powerful? Resource safety. By tracking ownership, move ensures that resources are never accidentally copied or destroyed. Concurrency. The borrowing rules, only one mutable reference or any number of immutable references, help prevent data races. Clear intentions. The ownership model makes it clear when you're transferring ownership of a value versus just looking at it. Compared to other languages like Solidity, Move's ownership model provides stronger guarantees about how resources are used and modified. This can prevent many common smart contract vulnerabilities right at the language level. As you write more complex Move code, you'll find that thinking in terms of ownership and borrowing becomes second nature. It's a powerful tool for writing secure, efficient smart contracts on Aptos. Alright, let's talk about keeping your Move code robust and reliable with advanced error handling techniques. In Move, we handle errors primarily through abort statements and custom error codes. This might feel different if you're coming from languages with try-catch blocks. Let's start with a simple example. In this example, we're using assert statements with custom error codes. If the condition in assert is false, the transaction will abort with the specified error code. The error invalid argument function is a part of Move's standard library. It's a way to create standardized errors that can be easily understood by tools and other developers. For more complex scenarios, you might want to use the if statement with abort like this. Here are some best practices for robust error handling in Move. Use descriptive error codes and constants for better readability. Leverage the standard error categories from the error module when appropriate. Be specific about error conditions to aid in debugging and improve user experience. Use assert for simple checks and if with abort for more complex logic. Remember, in Move, all errors are fatal to the current transaction. This means you need to think carefully about your error conditions and handle them appropriately. Now let's take a tour of the Move standard library. It's packed with useful modules that can save you tons of time and help you write more efficient code. Here are some key modules you'll want to get familiar with. Standard vector for working with dynamic arrays, standard operation for handling optional values, standard string for string manipulation, Aptos framework fungible asset for creating and managing fungible assets, Aptos framework object for working with Aptos objects. Let's look at a quick example that uses a few of these. In this example, we're using vector to store multiple balances, option for an optional admin address, and the fungible asset and object modules to work with Aptos specific concepts. Here are some tips for effectively using the standard library. Familiarize yourself with the available modules. The documentation is your friend. Use standard library functions instead of reinventing the wheel. Pay attention to the abilities required by different standard library functions. Don't be afraid to combine multiple standard library modules in your code. Alright, Aptos developers, we've covered a lot of ground today. Let's do a quick recap of the advanced Move concepts we've explored. We started with generic types and abilities, learning how to write flexible, reusable code that can work with different asset types. We then dug deeper into structs and resources, uncovering advanced features and best practices for designing your data structures. We explored Move's unique ownership and borrowing model, which is crucial for writing secure and efficient smart contracts. We also covered advanced error handling techniques, learning how to make our code more robust and user-friendly. Finally, we took a tour of the Move standard library, discovering powerful tools that can streamline our development process. These advanced concepts are the building blocks that will take your Aptos development skills to the next level. They'll allow you to write more sophisticated, efficient, and secure smart contracts. But remember, like any programming language, mastering Move takes time and practice. I encourage you to experiment with these concepts in your own projects. Try rewriting some of your existing contracts using generics or see if you can optimize your error handling. In our next video, we'll put all of this knowledge to use by building a more complex DeFi application. We'll leverage these advanced concepts to create a multi-asset liquidity pool with advanced features. It's going to be exciting, so make sure you're comfortable with what we've covered today. Thank you, and I'll see you in the next video.